Pues bueno, en el espíritu de estar a tiempo, vamos comenzando con esta plática que es la última plática antes del break de la comida. Ya saben que con su entrada de Posadep tienen su comida asegurada, entonces, bueno, de acá nos vamos a comer. Y bueno, tenemos una plática que se llama Deploying Thousands of MySQL DBs Using Rails and Kubernetes de Jonathan Gnagy y José Albornoz. Muchísimas gracias. Un fuerte aplauso para ellos, por favor. Y les paso el micrófono.
Hola a todos, bienvenidos, siéntense un poquito más adelante, estamos bien como digo, así que no se preocupen, vengan para acá, así nos escuchan mejor. You can start.
Okay. Testing, testing. Hello, everybody. Good afternoon. Buenas tardes. Welcome to our talk. Sorry that it's going to be in English, but entiendo más que puedo decir, so you have to bear with me on my English here. So we're going to be talking about deploying thousands of databases using Rails and Kubernetes. Hopefully you're all in the right place, and thank you so much for coming. I'm sure you're all hungry. I'm Jonathan Gnagy.
Yo soy José Albornoz. So let's get started. Goes in one? Okay, so we're gonna do it this way. So today we'll be talking about databases. Has yours ever gone down? For many applications, when the database stops working, the entire app stops working. Jonathan just mentioned thousands of databases, but why do we have so many? Millions of merchants rely on Shopify. Chances are high that you actually bought something from one of our stores. But with so many databases, there's more chances for things to go wrong. Thousands can go down any single time. For us, when the database goes down, it means that people can buy things, and we don't like that. We want commerce to keep going. So today we'll talk about why this is a hard problem and details about KSQL, the database system we developed to help solve some of these problems.
See if I can get this working this time because I have some confusion. Okay, first I'm going to read a quote. The hardest single part of building a software system is deciding precisely what to build. By that, I mean, this is kind of our disclaimer slide. What we're talking about, we needed, but it may not apply to everybody else. Sometimes canned solutions may work, or a simpler set of tooling may be enough. No, okay. Yeah, I'll try it with this.
Yeah.
We'll see. But for us, we needed tight control over all the operations that occur with our databases. So we needed to really understand how the system was going to behave and be able to control when certain things happen. So we decided to build our own platform, and we called it KSQL. What we needed, oh no, darn. Yeah, there we go. I'll just be here. So what we needed a full-fledged orchestration tool. Yeah, it's just that way. We needed a robust task engine. We needed an API, and we needed integrations with internal systems. We needed very quick failovers. And we needed flexible topologies. We'll get into what I mean by that in a bit. We also needed access to basically all the MySQL settings. Again, maybe everyone else doesn't need all of that. In any case, we hope that this talk will be interesting either way, even if you don't find yourself needing a tool like this or operating at our scale. So here's the agenda for today. But before diving deep into the technical aspects, we wanted to kind of give away what we're going to be talking about right away. So we have a takeaway slide. Look for these topics throughout the rest of the talk, and that way it'll kind of give you the themes through the whole talk. Then we'll go ahead and explain what KSQL is, how it works, and how we use Rails to help us scale. We'll also throw some demos in there, and we should have time for a Q&A at the end.
Sí, y estamos perfectamente cómodos en hablar en español, así que al final o después en el pasillo, si algo no entienden o tienen más preguntas, acérquensenos y les respondemos cuando se sientan totalmente cómodos. So, I hope you don't mind spoilers, but as Jonathan was saying, the talk can be a bit heavy, so we thought we're just going to give you the punchline right away. As you've seen, it's crucial for us that MySQL stays up, so we're going to talk in detail about why this is so hard and going to cover topics related to MySQL high availability.
As you heard, we'll also be talking about Kubernetes, and we'll be talking about deploying stateful systems using Rails on Kubernetes. We used a Rails app to help us do this. A lot of times when people are working with Kubernetes, they'll just write a controller. So a common question might be, why bother with a Rails app when you can just write controllers? For us, though, because we're managing MySQL, the truth is that can be tricky. There's certain nuances with operating MySQL, especially in large environments, that it just doesn't lend itself well to writing controllers to perform those behaviors.
Lastly, we developed a novel method of expressing business logic within Rails that internally at Shopify has proven quite popular for infrastructure operations. But we also think this could be used for other applications as well. So we'll talk a bit in detail about this task engine that we have. That's me.
Mm-hmm.
That's me. So what is KSQL? KSQL is the database as a service that we built. It's kind of like Heroku, but for MySQL. If you work at Shopify and you need a MySQL database, you'll go into our system and request it. We used all of these technologies to build it and many more. So let's see a demo. We're going to kick off a deploy right now. So what we have here is a KSQL manager. Let me see my notes. Is this the right place? No, I should just demo what's going on here. So what we see here is KSQL manager, and we're going to just start the deploy over here. So as you can see here, we have the name of the database called PostDev. We have MySQL 8, which is regions, different things like, for example, the size. And that's pretty much it. So we're going to go and start it.
Yeah, and as Jose hits the create button and starts the deploy, there's going to be a lot of stuff happening in the background. Don't worry too much. We're going to come back to this as we finish our talk.
Computers are computering.
Yes.
1 second. I want the deploy to start. Okay, we can go. This is kind of like a cooking show. So you just saw KSQL Manager. We think of it as the brains of KSQL. KSQL Manager is also the control plane of it. It's written as a normal Ruby on Rails application. It has a MySQL database itself. It's the UI where we do operations, database configuration, deployment, backups. It has all the logic for us. It's our single source of truth. We also have this very powerful task engine in KSQL Manager that we wrote, where we express the business logic in Ruby. This allows us to express complex workflows in a way that, this allows us to express complex workflows that normally would require many more steps for people to do manually. But over here, we write software for it, and then the computer does it automatically. And what's cool about this is that it allows us to write small tasks that we then compose, allows us to reusing much of our logic.
Yeah, and as I mentioned before, like why have this manager, this Rails app at all? I touched on it a little bit, that controllers, they're just not quite cut out to do what we need it to do. And in particular, these tasks that we write to help us perform these activities are really the reason for that. The idea is we write these complicated workflows, or at least rather, they would be complicated if we did them manually or tried to implement them in a controller. But because we create all these composable pieces and can stitch them together, and because KSQL Manager, this Rails app, understands the situation beyond a single Kubernetes cluster. So controllers tend to be very cluster-centric, and so they really only have control over what else is happening within that cluster. They can make external calls and things like that. But what we really needed is something that could understand our entire environment, and we use many, many Kubernetes clusters. So KSQL Manager is able to do that for us. It can actually understand what we mean when we say we want to change where the writer lives, and understand that that involves operations across multiple clusters. All right, so we talked a little bit about that architecture, but now we're going to dive a little bit deeper. There's a lot on the screen. Don't worry, I'm going to go through it very quickly, and then we're going to build up to this slide through the next slides. So here we have KSQL Manager. It's the Rails app I've been talking about. You can see it kind of lives outside of those clusters. Here are the database clusters. You can see there's a writer and a replica over there, each in their own cluster and own namespace. here's an app cluster. And here's an app. I call it app A. It's a simple app that has a web server and a job runner, a worker. And here you can see an important part of our Kate-SQL infrastructure, the proxy SQL. Instead of the app or the worker connecting directly to the databases, it goes through this proxy, which understands where the databases are and can route traffic appropriately. And finally, we have Watchkeeper. Its function we'll get into a little bit later, but it helps us with failovers and certain MySQL-specific operations that it's best to just leave in something dedicated. So let's start here. Something simple, just some apps. We've got app A and app B. So far, they've been able to be completely stateless. They didn't need databases, but the time has come for them to persist some data. So just like you saw José do, the owners of app A could go into Kate-SQL Manager and create a Kate-SQL. When Kate-SQL Manager creates this Kate-SQL, one of the first things it does is create the writer and wait for it to be healthy. So it boots up and runs some checks and makes sure it's ready to go. We expect that this very thing is what's happening in the background right now while I'm talking. After the writer's up, the next thing Manager does is create a replica. Replicas are created using snapshots of the underlying disk. And in this case, it's a snapshot of our brand new writer. The replica is then configured to follow the writer, which basically means it subscribes to changes to the writer and applies them. And once it fully catches up, meaning it has all the same data as the writer, Kate-SQL Manager sees that it's healthy. As I mentioned before, the proxy SQL is pretty important. It's how we achieve high availability for MySQL. What it is, it's an open source tool that speaks MySQL, and you can configure it and give it information about where your MySQL servers are running. Manager deploys this directly into the application's namespace and makes it simpler for the app to connect. Now here it looks like Manager's deploying one thing. In reality, this is actually several pieces. There's the actual Kubernetes deployment, there's a secret, config map, all that sort of stuff. And here we can see what happens when app A starts writing. Proxy SQL sees the insert statements and says, oh, I need to send this to the writer. And it knows where the writer is, so it routes that traffic. And then asynchronously, there's the replication that happens to catch the writer up, or the replica rather. So what we just showed is the process of how Kate-SQL bootstraps a brand new database. This is Kate-SQL Manager's job. This is what it does for us. The thing is, it does it for us over and over again at scale. And it coordinates all the work. For us, it's just a few clicks, like you saw José do, or API calls for some of our other tooling.
That's right. Actually, just a few minutes ago, you saw us creating our very own post-dev Kate-SQL. So let's take a look and see how that's going. Now, this is the part about demos that we'll see how it goes.
Yes. Everybody cross their fingers.
Let's see.
Hey, look at that. It finished successfully. That's a good sign.
All right. So yeah, it did work. Oh, I see there that we have running MySQL. So what we see here is our view of it, essentially. Just like the diagram that Jonathan explained, we follow the 2+2 topology, meaning that we have a single writer where the writes go into, and then all the inserts are replicated into all the other databases, essentially. They all have the same data. You can see we have 2 in US East and 2 in US Central. So sorry, Manager is the tool we use to do our operations. And as part of that, it tries to be very helpful for us. For example, it shows us some handy kubectl commands that we can use to connect to MySQL, which is what we're going to do right now. So we copy this and
keep going. There you go.
There we go. We paste it here. Oh, and so what we're going to do right now is connect to the live production MySQL for post-dev that we created just now. Let's see if it works. Drum roll, please.
All right, we're connected.
Okay, so we got a few queries to. Oh, sorry, to pull the queries are here.
Did I think I put the notes on? Oh, I put them on the wrong one. Sorry.
We're good.
Okay.
So I just need to do some copy pasting. So I don't know where the mouse is. Okay, so the very first thing we'll do is just gonna see the databases. Jonathan, could I ask you to hold the microphone for me?
Yeah, of course.
Thank you. Sorry. So this is just my SQL queries we're doing. I'm going to instruct it to use the one we just created. So, oh, could you move a bit? No, you're sorry. So what we're doing here right now is just an SQL query to basically see which MySQL server we're connected to right now. In this case, we can see that is CXSUE, the one shown just there, our writer. So let's now create a table. So we have an SQL query here that creates a table for us. We're Shopify, so we do discount codes. So let's also do an insert on this table. This is really just to show that we have a running MySQL that we can send queries to. But these are some of the operations that we do normally as we do maintenance on the databases. Other features that before that, let's actually, so some of the features we can do with Kate SQL. Oh, I don't know what I did.
Oh, you went to the bottom of the screen.
Sorry.
Sorry.
Can you, where's the mouse?
There you go.
Okay, perfect. Sorry. I wanted to show this section on the right. This is where we do many of the operations that we do. For example, you run another SQL console, but through the web. So you can see there the table that we just created, and we can even do.
It's easy to miss what's happening here, but this is the web-based read-only console that we implemented in KSQL Manager. And you can see here the new table and database that we created in the writer. It shows up via the replica that we queried to populate this view.
And that's the insert we did just below. One last section I want to show you of KSQL Manager is how it allows us to configure the MySQL databases. For example, here you can see the MySQL users section. We have different users, and if we want to, for example, create new users, we'd go here, set the grants, and then deploy it. So that's it.
Great job, José.
Thank you. Sorry.
All right. So now that we've shown how a single KSQL is deployed and some of the features that we can perform with KSQL Manager, it's time to dive a little deeper into how KSQL Manager helps us scale this process to thousands of databases. I mean, all of everything we did there was all great for one database, but how does it help us do it at scale?
So there's two aspects to this. One is the SRE model that stands for Site Reliability Engineering. The idea is to basically treat operations, that means keeping the servers up, as a software problem instead of like a human problem where we go and like SSH into the servers, just like I was doing. Basically, we want to automate the repetitive tasks so the computer does them, and we don't get to do them ourselves. A good example of this that we're very proud of is MySQL version upgrades. Recently, we had to upgrade from MySQL 5.7 into 8. This is a task that in a different technology stack would require many commands done by many people to make sure that everything goes through, but we automated it to such level that for us, it's also just a few clicks.
Yeah, that was a pretty intense project. Thousands of databases all upgraded and no downtime, which was great. The other aspect is configuration management. This is a big part of what KSQL Manager does for us. We built into the system an understanding of what it's deploying. And by that, we built a configuration schema that understands MySQL settings or Kubernetes settings or Proxy SQL settings and knows how to validate those both for valid values individually, but also in a certain context. Like it understands that, oh, if I set the Kubernetes stateful set to have a particular memory limit, that you can't then request a value above that limit and things like that. So we really made it so that it understands what it's deploying. Yeah, some of the other features of that configuration is also because it understands MySQL, it can perform activities that require a complete understanding of all of the environment rather than just one Kubernetes cluster at a time. So things like doing replication, like we were just showing on the screen, but at multiple layers where we can have intermediates in between. That's a feature that we can offer in KSQL because it understands what we're having it do. And specifically for configuration management, because it's so important, I want to spend a little bit longer talking about how it works and how it works at scale. So it's a little complicated, so bear with me while I go through some slides, but it all makes sense when I'm done, I promise. At first, they started out pretty simple. They were just key value pairs. Oh. Oh no, I'm not there yet. Thanks.
Sorry.
No problem, no problem. So the configuration started out very simple, but then as we built intelligence into KSQL Manager, we needed the schema, and so really there are these benefits of the schema. So I talked about a little bit of the contextual information, but there's also just being able to link to notes and documentation. So when you go to actually edit certain settings in KSQL Manager, it knows that, hey, the thing you're trying to configure, here's the docs link for it, so you can go read up on that setting. Or here's some notes that we added for our users so that they understand, here's kind of the comfortable bounds for settings on, or for the values of this setting, so that they don't go off the rails. Those contextual validations I talked about earlier. So not just saying, hey, this setting can only have these values, but you can't use this setting with some other setting, like that is invalid. Or this setting doesn't apply because you're using MySQL 8 instead of 5.7. Or it doesn't apply because you're trying to configure a proxy SQL, so MySQL settings don't matter there. And finally, it also understands if a setting requires the restart of a MySQL process. This is super important because some settings you can just apply live and Manager understands this, but others you have to actually restart processes. So that could potentially be downtime if we don't coordinate that appropriately. So building that smarts into KSQL Manager was very important. That skipped too far ahead. Oh no, okay, sorry. Yeah, there we go. That's better. All right, so here is, I'm going to dive into how these configurations work at scale by talking about multiple KSQLs at once. So on the left side of the screen here, we have a group of KSQLs. I gave them simple names just to make it easy. But what we're going to talk about is I here, the bottom right corner. In particular, this KSQL I right now is a member of a collection. It's called KSQL All. As the name suggests, every KSQL is automatically a member of this collection. And so therefore, any configuration that we add to that collection is automatically applied to every member of that collection. So every KSQL sees this. You can think of it as kind of like sane defaults that we set up for our KSQLs. So you can see something sort of like a little stack here. You've got the KSQL on top, the I, and then you've got KSQL All. And what happens is we have a resulting configuration. Pretty boring right now because it's just a member of one collection. We'll get to that in a second. So we have collections that are based on attributes of the KSQLs themselves. So in this case, let's say that this KSQL is a large KSQL. The one Jose made was small, so this one, it needs a little bit more memory and CPU. So because it's a member of the large, or because it is a large KSQL, it's automatically made a member of shape large. And because large KSQLs are probably doing more things, maybe we set a different configuration on this one. Maybe we gave it 3 replicas instead of 1. So you can see the resulting configuration on the bottom for I now is, it's different. It now includes 3 replicas, which I highlighted in green there. And we were talking about MySQL versions. Let's imagine that our KSQL runs 8034, just like the one Jose created. Because it runs MySQL 8, it's automatically added to the MySQL 8 collection. And so we set some MySQL specific settings on here. This one's made up, obviously, but this is to show that this stacking behavior of these configurations doesn't just override values, it allows us to introduce new ones as we go. Here we've created a custom collection, and we've added some KSQLs to it, which is represented on the left there with the yellow rectangle. So this custom collection, we've added a couple keys to it. And you can see here, it gives you an idea of how these collections are ordered or how there's a preference or priority to them. Custom collections are the highest priority. Because you have to go through the work of manually adding things to these custom collections, it feels kind of intentional. So we wanted to give that the highest priority and make sure those settings show up. So here's the final result of all these collections. Finally, the last piece is what if we want to configure just that one KSQL? So rather than using a collection, we can go all the way down to one KSQL and add some configuration overrides there. So here we said, hey, this KSQL is busy. We're going to give it 4 replicas instead of 3. So at the end there, you can see the final merged configuration. One important note, as I've been talking about these configurations, is they are not applied as soon as they are present. So right here, you can see all these configurations are attached to this KSQL. You can think of it that way. But they aren't deployed live as soon as these configurations show up. You have to actually go through a deployment process, like Jose was showing. And it bundles up these configurations and actually applies them to the running MySQL processes.
So one of the things we like the most about KSQL is how it helps us automate complex operations. A common procedure we do, we call instance replacement. What you can see there is an example of the positive KSQL we deployed just now if it was connected to a working application. The idea of this instance replacement procedure is to create the database in a new place and then move all the data there, so we then shut down the old one, basically to swap them, so we don't turn it down, essentially. We do this process when we need to upgrade Kubernetes clusters. We don't upgrade in place, but we create a new cluster with a new version and then move all the databases into the new cluster. Also, if we, for example, as Jonathan was saying, if we need to resize the KSQL, that requires a restart. So what we do is create a new KSQL of the larger size and then move the data there. So let's see a bit how it works. So let's say that we have the positive KSQL and we want it to go from small into larger. As we start the instance replacement process, the first thing that happens is that KSQL Manager creates the new replica that you can see over there. We set up the replication in such way so it works just like with the other MySQLs, and you can see there how it's copying the data from. Thank you, Jonathan. Something I like about this is that we reuse the very same logic from the normal KSQL deploy, so we had to write very little code to make this happen. You'll see this throughout the talk. So once the new instance finishes catching up and gets all the data from the other ones, we do what's called a graceful takeover. And we promote the new writer, the old replica MNO, to become the new writer. And then we send proxy SQL, so all the queries start going to that new writer. After traffic is moved, we just go and delete the old database so we don't waste any more resources. And this is what we call an instance replacement. And for us, it's the equivalent of turning something on and off again. Basically, we just press a button in the computer, get the database in a new server, and it fixes most of our problems, which we really like. So it's a bit hard to read the text, but this is a more detailed screenshot of what one of these operations looks like within KSQL Manager. What I like about this is that the task engine allows us to interweave all of these tasks. So each one is actually very, very little. You can see that they run in like 100 milliseconds or so. And so some noteworthy tasks that we want to mention from here are the wait for instance ready task. What we do is we send an API call to Kubernetes, and then we have a task waiting for it to actually be applied in Kubernetes before moving forward with the deploy. Then we have the actual graceful takeover that we saw on the slide where we changed the writer from the old one into the new one. And something cool is that we managed to group all of these tasks into like buckets. So we teach the system how to replicate this. So what you saw here is what happens for a single MySQL, but we have 4. So the computer just knows how to do it for all of them automatically and does the failover right at the end.
Yeah, to emphasize that a little bit, there's a lot going on the screen, right? There's a lot here. But we showed this way on purpose because we want you to really understand if we were to run all these processes manually, it'd be quite a bit of work. And everything that you see here, everything that you see here, this is all the expansion of just this one task, this one workflow. And this actually performed all 4 of them concurrently. So it's able to provide this parallelism that we need to be able to operate at the scale that we do.
There's a lot that we could talk about the task engine, but we couldn't fit it in the presentation. So if you have questions, now's the time.
Yes, that's very true.